Okay, here comes 5.2.2. What happens when we know that two polygons are in fact similar, right? So if we know the quadrilateral ABCD is similar to EFGH, then we know a lot, right, about congruences and proportions. Now, the order is super important here. So this says A, B, C, D, right? In that order. 2, 3, 4 is similar to, right? E, F, G, and H, right? So one of the things I'm going to suggest often is that we put these figures, if we can, in our head or on a screen and try to align them to look alike, because right now this green looks a little off from the purple, and it might be helpful to turn it around a little bit. So I've created these things to not be terribly movable, except when I need to. They're called rigid polygons rather than movable, and in this case it's just really helpful if I simply start putting things in the same position. Now it's a little bit easier to see what I'm talking about and how we can use, for instance, angle A. If we know the two polygons are similar, we know that A and E are the exact same measure, right? B and F, right? Is that right? Yes, B and F are congruent, right? They're not congruent to each other. H and D line up, and G and C line up. 1, 2, 3. Really important. Those tend to be pretty straightforward for people as they're studying this. What's a little bit harder to see is all of these relationships that now become locked in now that we know that the two quads are similar, right? We know that AB, and let's see if I can do this with some other color here, maybe purple, that AB, right, this side, relates to EF. If you read along the bottom and see what I'm doing, the same way that BC relates to FG, the same way that DC, let's see, this side relates to this side, is the same way that this side relates to this side, right? And all that matters is that these all relate in a certain way. So for instance, if I were to throw some numbers in here, we could figure some things out. So let's say this is 2, this is 4, right? Right away, I know that the scale factor between purple and pink and green is a 2 to 4 ratio, or basically a 1 to 2 ratio. And so whatever this length becomes, this will be, whatever length this length becomes, this will be twice that. So for instance, this could be A, this will be 2A. If this is X, this will be 2 times X. And if this is K, this will be twice K. Why do we know this? Because we know that the quadrilaterals are similar, and therefore their sides have to be in the same proportion. In this case, the proportion would be a 1 to 2 ratio that is preserved all the way around all the sides.